All right, for this lesson, we're going to start taking a look at solving radical equations. Now, in this case, we're going to do it by factoring, but we could actually use the same process using quadratic formula, completing the square, whatever you want. Any of the algebraic methods that you've used to solve quadratic equations. So, to begin with, we're going to take a look at what these look like. So, we're going to start by graphing y is equal to the square root of x. On our grid, we can plug that into our calculator, pull up the table of values to find points. And we know that the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and so on and so forth. And you're going to wind up getting something that looks like this. Now, what is the domain of these values? That means what is every x value that we can see exist? Well, we can have an x value on any of the positive values here, but x doesn't exist in any of the negative values. And that makes sense because we can't take the square root of a negative. So the domain is going to be x, where x has to be greater than or equal to 0, and x is also a real number. For what values of x is the radical expression defined? Well, that just means for what values of x would make this mathematically possible, as long as x is greater than or equal to 0. It's going to mathematically work. I can take the square root of 0, 0.5, 26. I just can't take the square root of a negative. Looking at the next example. If I take the square root of x minus 2, then what happens? Well, I'm going to plug it into my calculator. I look at the table and I get the point of 2 and 0, and 3 and 1, and 6 and 2. And it has almost the exact, or it looks almost identical to the previous example we had. All that's happened is it has been shifted 2 to the right. What's the domain going to be here? Well, in this case, it's represented by x, and x only, the function only works if x is greater than or equal to 2, where x is a real number. For the radical expression, what is the restriction on x? X has to be greater than or equal to 2. How can I determine the restriction algebraically? Well, we know that the restriction for any radical is radicals are only possible, or square roots are only possible, if there is a positive number, or 0, as a radicand. So you need to state the radicand is greater than or equal to 0 then isolate the variable. When we get to the next example, if it says that root 3 minus 2x, I'm going to plug into my calculator. It starts at 1.5 and 0. And then this one actually goes in the other direction. Well, what's going on here? In this case, x has to be less than or equal to the x-intercept of 1.5 or 3 over 2. if I'm determining the restriction algebraically, then I would start the same way that we did before. The radicand has to be greater than or equal to 0. I'm going to move the constant over by subtracting it from both sides. And this part you may or may not have known before. If I'm isolating a variable in an inequality, so it's greater than, less than, whatever, if I need to divide by a negative or multiply by a negative to isolate the variable, then what happens is the inequality changes direction. So suddenly it's going to be x is less than or equal to 3 over 2. The other way we can think of it is inside the radical, if the coefficient of the variable is negative, it's going to be less than. If the coefficient of the variable is positive, it's going to be greater than. Works the same way. So, when we're doing radical equations, a radical equation is just any equation which contains a radical. A value of the variable which satisfies the equation is called a root of the equation, just like what we had in quadratics. We are going to solve these graphically and algebraically. So to begin, we're going to do this by finding the restrictions on the variable. When I'm finding the restriction on the variable, I'm going to say that 4x plus 1, what's inside the radicand, has to be greater than or equal to 0. Anything that's not inside the radical doesn't matter for a restriction, which means that 4x is going to be greater than or equal to negative 1, or x is going to be greater than or equal to negative 1 over 4. And there's my restriction. In the second case, just look at the radicand 2 minus 5x is greater than or equal to 0. Negative 5x is going to be greater than or equal to negative 2 when I move it to the other side. And when I divide both sides by negative 5, x is going to be less than or equal to negative 2 over negative 5, or 2 over 5. For example, C, there's 2 of them here. So I'm going to solve these independently. I'm going to say that if x minus 2 is greater than or equal to 0, then x would be greater than or equal to 2. In the other case, if x minus 4 is greater than or equal to 0, x has to be greater than or equal to 4. Because both of these need to be true, I could think of it like how it would exist on a number line, where I'm going to have the 2 possibilities at 2 and at 4, and if a number needs to be greater than or equal to 2, and it needs to be greater than or equal to 4, we can see that any number that is greater than or equal to 4 will always be greater than or equal to 2. So that's going to be my restriction. My restriction is where it's going to account for both possibilities. And it has to work for both, otherwise it just doesn't mathematically work. I can do the same thing with the next one, where I can say that x is going to be greater than or equal to negative 2, and x is going to be less than or equal to 3. And like what we had before, if I put this on a number line, if it has to be simultaneously greater than -2 and less than +3, then it only works when it's between these 2 points. That's the only case where it's going to work for both of them. So how do I state that x is between 2 points? Well, -2 is less than or equal to x, which is less than or equal to 3. When I go to the last one, I'm going to say that 2x minus 7 is greater than or equal to 0. 24 minus 5x is greater than or equal to 0, which means that 2x is going to be greater than or equal to 7, or x is greater than or equal to 7 over 2. And here I have negative 5x is greater than or equal to negative 24, or x is less than or equal to 24 over 5.